You've probably heard the term percentile. Most likely it was in this context. You've heard of somebody maybe getting in the 90th percentile of their class. Let's say that there's an exam, and the exam marks are being, or the exams are being handed back, and your teacher tells you, good job, you're in the 90th percentile. Now, that doesn't mean that you got 90% on your exam. You could possibly have failed your exam, but still be in the 90th percentile. What this means, this 90th percentile, this is actually what's called, and this is going to get a little bit confusing in terms of the terms that are used. This is what is called a percentile rank. This 90th percentile is a percentile rank, not to be confused with a percentile, which I'll discuss in a moment. So the term percentile is actually, in common language, really a percentile rank. And what it means is that 90% of the class scored equal to or lower than your score. So remember how I said you could have failed but still be in the 90th percentile? Well, let's take 10 students from the class. And maybe the top mark was barely a pass. It was a 52. And your score, let's say you failed, you got a 46. Well, as long as the other ones are lower, you're in the 90th percentile. So there could have been 2 people that got 40s, and maybe a couple of people were in the 30s, and then everybody else after that was 20 or lower. So, and a 2. So if this was, let's say your class is very small, there's only 10 people, you got 46, so let's highlight you there. You are in the 90th percentile. The reason for that is because only 10% of people scored higher, whereas 90% scored equal to or lower. So that would put you in the 90th percentile of the class. It doesn't mean you got 90% on your exam. We can see here you only got a 46 in your exam, but you are, once the class is put into order in terms of their marks, you are the dividing point between the lower 90% and the upper 10%. So that's what the 90th percentile means when it's talking about, or that's what a percentile rank is. It tells you where your particular score falls in the distribution. Your score itself, the 46, this is what's referred to in this course as the percentile. So a percentile, actually let me make that a little bit easier to see. The percentile is a score. A score is a percentile is a score, but the percentage, that is referred to as the percentile rank. Personally, I always found this easy to mix up. So you're going to want to have, if you're not allowed to make your own cheat sheet, you're going to want to have some little mechanism for keeping track of which one means the score and which one means the percentage. Maybe the best thing to do is simply just practice a number of the questions and make sure that when you're reporting the percentile, you're giving a score. So if they say, what is a particular percentile, make sure you don't say something percent. You're giving them an actual score. If I said, what is the 90th percentile? The 90th percentile is 46. What percentile rank does 46 have? It has a 90%. Its percentile rank is the 90%. It's the 90th percentile. it's a little confusing until you've done a number of examples like this. So what I'm going to do is I'll do an example with our data on the number of siblings. To do that, I'm just going to clear this up, clear out all of my chicken scratch over here. And I'll show you how you find percentiles and percentile ranks. In order to create a listing of percentiles and percentile ranks, the first thing we need to look at are what are called cumulative frequencies, which I'm going to represent as a column here, CF for cumulative frequency. Now, cumulative frequency means you're going to accumulate your frequencies starting from your lowest category. So down here where people said that they had the lowest amount, 0 siblings, I have a frequency of 3. So far I have accumulated 3, which means that 3 people have a 0 or less. When I get to my next category, some people had 1 sibling. In fact, 7 people said that reported that they have 1 sibling. So what is my accumulated frequency up to this point? Well, I had 3 already. Now I'm going to add in these 7 people. So I have a cumulative total of 10. That's just the 3 plus the 7. And so you can see that this is going to build as we go through. So when I get to my next category, it's going to be the 10 that I already have. So that was the 3 and the 7 makes 10. Add in the next 10, and that brings me up to 20. That 20 signifies that there are 20 people that have 2 or fewer siblings in the sample. And then add the next 3 in. That brings me to 23. Then add the next 4 in, so that's 27. This category had nobody reporting that they had 5 siblings, and so that doesn't add anything, and it leaves me at 27. And then finally, when I get to my last or my highest category, there's 1 person that said that they had 6 siblings. We add that to the group so far, the accumulated total so far, and I get 28. And the 28 might seem familiar because, remember, when we wanted to find our sample size, we just added up the frequency, and our frequencies added up to 28. These 2 numbers should always match. So when you're finding cumulative frequencies, if you're creating this column, you have to make sure that in your highest category, you're going to end up having the sample size. So it's a quick way to check your math before carrying on. And we are going to carry on because we have to create one more column, and that is the cumulative percentages. Now, all that's happening with cumulative percentages is we're just going to take these values of 28 and 27 and so on all the way down to 3, and we're going to turn that into a percentage. In fact, these will end up being our percentile ranks. So that's what we're working towards. And the way that it happens is like this. We have to work with this formula. Cumulative percentage is equals to the cumulative frequency divided by n. And remember, I showed you how to get n. It's just the sum of your frequencies. And then we multiply that by 100%. So let's take a really simple example. Let's start off at the top here with 28. If I take my cumulative frequency of 28 and I divide by n, which is also 28, multiply that by 100, that's going to give me equals to 1 times 100%, which gives me 100%. Now, that makes sense. You should always end up getting 100% as your top cumulative frequency or your top percentile rank, because what we've done is we've looked at the highest category. And a percentile rank, remember, means how many of your individuals or how many people in your sample scored less than or equal to this score. So of course 100% of people scored less than or equals to your highest score. Your highest score is the top score, so 100% of people scored less than or equals to that score. But what about these other ones? Well, let's try substituting in the 27. So instead of the 28 being subbed in, it's going to be 27 over 28. Multiply that one by 100%, and that's going to give us how much? So I'll do 27 divided by 28, and then multiply this by 100%. It comes out to be 96.43. I'll round that to 2 decimal places. So 96.43. So this is 96.43 there in that row. And it's also going to be the same thing in the next row because my cumulative frequency doesn't change there. So of course, converting it to a percentage also won't change. But when I go with 23, well, that's going to give me a different value. 23 divided by 28 times 100%. Let's check that one out. So this is going to be 23 divided by 28 times 100. It's 82.14. So this is 82.14%. All right, so let me quickly run through the last three, and then I'll talk about what these mean. Okay, so what do these mean? Well, remember, these are my percentile ranks, and so that means that this 10%, for example, this 10.71% means that 10.71% scored in this category, this lowest category, or lower. 82.14% of people scored in this category of 3 or lower. So these are my percentile ranks. So does that make the X values, my scores, does that make them the percentiles? Not quite. We have to be a little bit careful about that. Let me show you what I mean. Now, if I wanted to talk about any one of these categories, let's take this category of 3 here. I can't really say that 82.14% of people scored or reported a score of 3 or lower because the category itself covers a range. It goes from the lower real limit of 2.5. Remember, to get to the lower real limit of a number like 3, you have to go a half step below. So 2.5, it goes, this category stretches up to an upper real limit of 3.5. So if I want to talk about 82.14% being less than or equals to this category, well, anybody who has reported a score up to 3.5 is in this category. So I would say that 82.14% of scores are less than or equal to not 3, but 3.5. And the same is going to be true for every one of my categories. So 100% of scores aren't less than or equals to 6. They are less than or equals to the upper real limit, which is equals to 6.5. So these percentages, or these percentile ranks, they don't really go with the scores, the raw scores that I see here. Instead, they go with the upper real limits of the scores. So if I wanted to create another column here, if I had to create a column of percentile, well, actually they're just called percentiles. Let me get rid of this. If I wanted to create a column of percentiles, then they would be 6.5 is the upper real limit of 6, and 5.5 is the upper real limit of this category, and 4.5, and 3.5, 2.5, 1.5, and 0.5. So 10% roughly, of people scored less than or equals to 0.5. 96.43% of people scored less than or equals to the upper real limit of 5, which is 5.5. So these are my percentiles, and these are my percentile ranks. So that's how this works. This is how you find percentiles and percentile ranks. If they were to ask me, what is the percentile rank of 2.5, then I would find 2.5, which is the upper real limit of this category. So I'd go to my 2.5, and then this is the corresponding percentile rank. So the answer would be equals to 71.43.